So we continue now with negations of statement. So I already have one example here. We define a predicate AX to state that X is fun. Again here, I would like to give you some trick to make it easier for us to find out what will be the negations of a statement is by trying to convert it to predicate logic expression first. Then after that, we read the statement accordingly. So for examples, as I mentioned here, I already define a predicate AX as X is fun. So my statement now will be everything is fun. Everything is fun. So what will be the negations of this statement? This is what we are going to see now. So I said earlier, before we try to figure what will be the negations of this statement, it is easier if we try to convert it first into propositional logic expression. Then we try to figure or give the negations connectives to that predicate logic, then convert it. So for examples, for this one, for everything is fun, we're going to have for everything that will be for all X. Fun here we already have the predicate as AX. So everything is fun. We can have we can have for all X AX. Now the negations of these expressions we can have here by add the negate connectives. So we are going to have not for all X AX. Okay, so we can read this one already to see what will be the negations of the statement, or we also can try to work with the connectives and try to simplify these structures. So like this, negate meet with for all. So in predicate logic it will convert it into there is X, and then the negate meet with AX, this will be not AX. So now we can also read this one with a different way, but will have the same meanings. So how is it sounds? We read the first one. For this, that will become it is false that everything is fun. So this is one way, is the negations of saying everything is fun. So we just need to say it is false that everything is fun. Or we can read using the second expressions here. So it become something is not, because we have the negate EX, is not fun. Okay, so now you can see there are two ways to read, but they have the same meaning. This is one with the expressions not for all x ex, and this is another one with expression there is x not ex. Okay, so you can try to look at which one is easier, rather than we try to find out the negate of this statement immediately without need to convert it first into predicate logic. You can see which method is sweet for you. Okay, let's see, we try to have another examples. So we said another statement, something is fun. So this is our statement now. Earlier is everything is fun. Now something is fun. What will be the negations of this statement? So we try to convert it first. For this something we have there is x, fun we have ax. So if we put all together, we have there is x ax. So the negations for this one, let me put the note here, negation. So this one also we can do the same. The negation, there are two ways as well. First, we just immediately add the negate connectives in front of the structures. There is x ax. Okay, or another way, so this is one way, or another one we can have like how we just did earlier. So negate meet with there is x, it becomes for all x, and then negate meet with ax, that will become not ax. So this is another expressions, but it's the same meaning. So again, we can read this one as it is false that something is fun. Okay, or we can read the other one, become for all x is not x. So everything is not fun. Everything is not fun. Or it's okay to, in this case, it's okay to change the scenario of not fun here. Not fun meaning boring. So we can tell everything is boring. Okay, or another way to say it is false that something is fun. It is false that something is fun. Also for this we can say like nothing is fun, like that. Okay, nothing is fun. So this is how we find a negations of a statement. But what I would like to highlight in here, when we try to find the negations of a statement, we're not only going to find the negations of the predicate only, like this: fun become not fun, fun become not fun. But at the same time also we need to find the negations of the quantifier, if there is any quantifier. So we already see in these two examples. So for all x, the negations for all x, that will become there is x. And for the extension, the negations of the extension, that will be become for all x. So remember that when we try to do the negations of a statement, we're not only going to negate the predicate only, but at the same time also we need to negate if there is any quantifier in that statement, as how we found out in these two examples. Let's see another examples. We have statement some pictures. Some pictures are old and faded. So some pictures are old and faded. So what do you think the negations of this statement? Can you make a try? Or another one, all people are tall and thin. Also for this one, what will be the negations of this statement? So I would like you to try convert it into predicate logic expressions. But I will give you the hint for the negate statement of these two statements. So the first one, we can say that some pictures are old and faded. Then we said for some, that will be every picture. Old and faded become is neither old nor faded. Okay, so this is the first one is the negations of the quantifier, and this one is the negations of the predicate, neither old nor faded. For the second one, all people are tall and thin. So for all, we have someone is tall and thin. We can have tall become short and become or, and thin we can change to fat. But instead of saying short or fat, you can just say not tall and not thin, something like that also okay. So this is the negate of the quantifier. Short is the negate of the tall, and fat is the negations of thin, or over here is the negations of n. So everything must be changed. You can try to write down the predicate logic expressions for these two statements, and we are going to discuss in this class, in the class later on, and see whether you can make it or not. Okay, so on the next video we are going to discuss regarding the validity of statement in predicate logic. Okay, so see you on the next video, and thank you.